Alright, Navy Electricity Electronics Training Series Module 1 Introduction to Matter, Energy, and Direct Current. Navy Try 14173. Alright, Chapter 3 Direct Current. Our learning objectives: upon completing this chapter, you will be able to identify the terms of the schematic diagram, identify the components in a circuit with a simple schematic diagram, start with the equation of the Ohm's law, describe the effects of the current caused by the change in circuit, give the simple graph of the current versus the polar, power voltage versus power, determine the value of the circuit power with the given current voltage, identify the term of the power C3 formulas for the power, computing power, complete circuit with the component power of the series parallel combination circuits. Compute the efficiency of the electrical device, solve the unknown quantity of the resistant current and voltage in series current and a series circuit. Describe how the voltage polarities are assigned when the voltage drops across the resistor and Kirchhoff's voltage law is used. Say the voltage at the reference point in a circuit defined on the open short circuit to describe the effects of it on the circuit. State the meaning of the term that sources of the resistance described and effect of the circuit. Describe the terms of the circuit value with the circuit condition need for the maximum power transfer, compute efficiency of power transfer in a circuit to solve the unknown quantity of the resistant current voltage in a parallel circuit. State the significance of the polarity assigned to the current when using the Kirchhoff current law. State the meaning of the term equivalent resistance. Compute the resistance and current voltage and power and voltage dividers. Describe the method of which the voltage divider can be provided with both positive and negative voltage. Recognize the safety precautions associated with the hazard of electrical shock. Identify the first aid procedure for a victim of electrical shock. Introduction. The material covered in this chapter contains the many terms that are explained within as your progress throughout the material. The basic DC circuit is easiest to understand, so the chapter begins with the basic circuit. From there, works on the basic schematic diagrams of the circuit. The schematic diagram is used in all future work with electricity, electronics, and very important that you become familiar with the symbols that are used. The chapter allows you also explains how to determine the total resistance, current, voltage, power, and the series, parallel, and combination circuit through the Kirchhoff law. Voltage dividers, the voltage network divider, series parallel, practice problem circuits will be the practice examples of what you've learned. Basic electrical circuit. The flashlight example of the basic electrical circuit contains the sum of the source of the energy of the dry cell with the flashlight load with the bulb with chain with the electrical energy in a more useful form of the energy light, which control the energy delivered to the load. Before you study the schematic representation of the flashlight, it is necessary to define with certain terms the load that is any device where the electrical current flows with chain with the electrical energy with a more useful form. The sum of the common example of the load light bulb will chain with the electrical energy, light entry, electrical motor will chain with the electrical energy into mechanical energy, and the speakers in the radio which chain with the electrical energy into sound. The source is the device when furnished with the electrical energy used by load. May consist of a simple dry cell as in the flashlight storage battery and as an automobile power supply such as battery charger. The switch permits the control of the electrical device to interpret the current delivered to the load. Your schematic representation technicians main aid troubleshooting circuit with a piece of equipment for the schematic diagram. The schematic diagram is a picture of the circuit that will use a symbol that represents the various circuit components. Physical, large, and complex circuits can be shown with a relatively small diagram before studying the basic schematic. Look at Figure 3.1 with the figure show of the symbol that used in the chapter. These other like them and refer to you throughout the study with electricity and electronics. Alright, a wire is just a line. Conductors connected would be either a joint with a full port, filled-in port, or crossing a point, and non-connected or just crossing without the port filled in. Ground is a series of smaller dashes in an equilateral triangle. Battery show the one larger plate, bigger plate. The battery, that's a cell. One large plate, one low cell is a cell. A battery is shows the number of plates short and long, or shows the number of shorts point and long with a positive and negative end. The lamp incandescent is a circle with a swiggle in it. A fuse is two ports with a swiggle in it. Fix is a zigzag variable parameter, a zigzag with a port with a triangle in it. The rheostat is a resistor with it goes from it connects back to a points back to the resistor. a port, and then points back to the resistor. Switch is a 2 ports, non filled in, broken wire in a door swing. Voltmeter is any engine symbol is used in a circle, but the V stands for voltmeter. Voltmeter, A stands for ammeter. Schematic diagram shown in figure 3.2 represents the flashlight. View A figure show of the flashlight when off with the de-energized state. The switch S1 is open with a no complete with the path of the current from 1 through the circuit, and the bulb, the DS1, does not light in the figure. In figure 3.2, view B with the switch S1 current flow for the direction of air with the negative terminal of the battery through the switch S1 through the lamp DS1 back to the positive terminal of the battery, which switch is closed with the path of the current is complete. Current will continue to flow until the switch is moved to the open position of the battery is completed in discharge. Alright, so the de-energized shows your battery positive and negative, 2 cell, 1 cell, 1 large plate, 1 lens, a switch S1, and your flash bulb DS1. Energize show that the switch is making contact with the battery and the lamp. In figure 3.2, what part of the circuit is A, load, and B, the source? What happens with the fast circuit of the S1 open shown in the figure 3.2A? What did the name give of the picture of the circuit shown in one shown in figure 3.2? Ohm's law, the earliest part of the 19th century, Gero Simon Ohm provided with the experiment that prescribed the relation exists between current voltage and resistance. The relation is called Ohm's law is stated as follows: the current circuit is directly proportional applied voltage, inversely proportional to current resistance. Circuit resistance Ohm laws may be expressed as an equation, or I is amperes equals voltage in voltage in volts, and R is the resistance in ohms. As stated in Ohm lamps, currently reverse proportional resistance. This means that the resistance in a circuit increase with the current decrease of the decreases proportionally. In the equation I equals E over O, the two chlorine with the third one determined, refer to figure 3.2b with the schematic flashlight with the battery supplied with a voltage of 1/2 volts, and the lamp has a resistance of 5 ohms. Then the current circuit can be determined. You have the equation. You have 0.3 amperes. Flashlight 2 cell would be twice the voltage, 3 volts, as applied to the circuit, and using the voltage in the equation. 5 volts is 3 volts over 5 ohms is 6.6 amperes. And see the currently is double the voltage, and the voltage is double. To demonstrate that the current is directly proportional applied to the voltage. Value resistance of the lamp to double in the equation will be the amperage is equal to the 3.0 volts over 10 ohms, which is 3 amperes. The current has reduced that 1/2 volt value with the previous equation of 3/10 of number of an ampere. This demonstrates that the current is inversely proportional with the resistance, doubling the value of the resistance load, reduce the current circuit current value to 1/2 of the former value. Applications Ohm law. By Ohm's law, you'll be able to find the resistance circuit known with only the voltage circuit in the circuit in the equation with all variables or parameters are known exactly with one known can be found. For example, the Ohm's law is I the current, E the voltage, and the resistance. The only parameter is not known can be determined. Basic formula: current or amperes is equal to voltage over resistance or ohms. So it's amperes over volts over amps is equal to volts over amperes. Remove the divisor multiply both sides of the R. Result is step 2 is the ohms times the amps equals the volts. To get the R alone, one side of the equation, divide both sides by I. Basic formula transposed to R is, so you have ohms is equal to volts over amps. The figure 3 equals 10 volts over, and 1 equals 1 amp, I equals 1 amp, so everything of solve for the ohms equation was just given. Given that the volts is 10 and the amps is equal to 1, the solution is 10 volts over 1 amp equals 10 ohms. 3.3 determine the resistance of the basic circuit. You have three. You have 3 short plates, 3 long plates, battery, and it's going in the current to the ammeter, and then the resistor 1, which would be should be 10 ohms. Insert the values known with the quantities. The resistance of the ohms equal to 10 volts over the amp that equals 10 ohms. The basic formula can be U with the solve with the E with the take basic formula. Amps is equal to voltage over the ohms. Both of us reply to the ohms. The amperes times the ohms equals volts over ohms times ohms over 1. I think that's 1. Results equals volts is equal to amps times the ohms. The question could be the voltage circuit shown in figure 3 and 4. All right, 1 I is your 0.5 amperes resistance is 45 ohm. Solution is that the voltage is equal to the half a amp over times 45 ohms equal to half of ampere times 45 ohms is 22.5 volts. You determine the voltage of the basic circuit. You have what is E with the 45 ohms? You would have so you have whatever half of 45 ohms is 22.5 volts should be. Ohm's equation vary for the forms may be obtained readily with the figure shown figure 3 through 5. The circuit containing the voltage amps and ohms is divided in 2 parts. For the voltage is above the line with the amp over the resistance below the line. To determine the unknown quantity for the first, cover the quantity with a finger. Position uncovered a lever with the circle that indicate the mathematical operation to be performed. For example, find a cover with a finger. With a finger, then uncover the letters indicating that the volts is divided by the ohms, or under the formula where the volts is covered by the volts. With your finger, result indicates that the amps is to be multiplied by the ohms, which equals volts times amps times ohms. Volts equals amps times ohms. With find the recover with the result of the volts to be divided by the amps, or R or ohms equals volts over amps. So you have your circuit with the Ohm's law diagram shown in the figure of form shows the amps is equal to the volts. Amps is equal to volts over the resistance or ohms. Your volts is equal to amps times the resistance, and your ohms is equal to volts over amps. You're calculating this shows the pie chart with an E, an I, and R, respectively. You're cautioned not to rely wholly on the use of the diagram when transporting Ohm's law. The formulas. The diagram should be used to supplement your knowledge in algebraic math. Algebraic is a basic tool solution for the electrical problems. According to Ohm's law, what happens in the circuit, the current is applied with the voltage A, then B increase the B. The decrease of the Ohm's law wouldn't happen happens the circuit is in the resistance. Then the A increases B and decreases what equation is U. Find the circuit where the voltage and current values are known. Our graphic analysis of the basic circuit. One of the most valuable methods of analyzing circuit is composed of the graph, with no other method that provides the much more convenient but the more rapid way with the above observe the characteristic electrical device. First step of the construction of the graph is obtained with the table of data. With the information from the table that can be obtained with the taking the measurements on the circuit under examination can be obtained theoretically through a series of the Ohm laws computations. The latter method is used since there are 3 variables, volts, amps, and ohms, to be analyzed with the 3 distinct graph that may be constructed with any graphical and electrical quantity. The same practice vary one quantity specified. Know the changes whether occur. The second quantity of the quantity, which is intentionally varied, is called the independent variable. Is plotted with a horizontal axis. The horizontal axis known as the x-axis. The second quantity varies the result of the change. And the first quantity is called the dependent variable. Is plotted with the vertical y-axis, and other quantities involved with the held inconstantly. Are held constantly. For example, the circuit is shown for the figure 360 with the resistance held with the 10 ohms of the voltage was verified, resulting in the current to be graphed, and the resistance of the constant would be the voltage and variable with the current depending on the variable. So you have your voltage coming from the battery, your resistance is your ohms, and your amps would be your wire. Figure 3.7 show the graph of the table available. The table show the resistance held with a constant with the 10 ohms and the voltage required for the 10 to 20 volts and the 5 volt steps. Through the use of ohms law, you can calculate the value of the current, the value of the voltage shown in the table. When the table is complete with the information it contains, can be used with the construct of the graph that's shown in Figure 3.7. For example, when the voltage is applied to the 10 ohm resistor of 10 volts, the current ampere is 1, and the result of the current voltage determines the point on the graph of the 5 points have been plotted, smooth curve drawn through these points. So you have a voltage ampere chart with the y-axis in the amperes, and the E in volts shows that you have steps of 0.5 on the y-axis and steps of 5 in volts on the x-axis, which is the volts. Your resistance is 10 ohms, so you have 10 volts. E over I, or 1 amp, and you have 10 volts. So your energy, your volts is listed in your amps voltage chart. So you feel the curve of the value of the current through the resistor can be determined by any of the following voltage: 0 between 20 volts. Since the curve of the straight line show with the equal chain of the voltage across the resistor, produce the equal chain of the current through the resistor. The fact illustrates an important characteristic of the basic law. The current varies directly when applied with the voltage. When resistance is held constant, the voltage across the load is held constant, but the current depends solely upon the resistance over the load. For example, the figure 3.8 we show with the graphic of the voltage held at constant at 12 volts. For the independent variable, the resistance would be varied from 2 ohms to 12 ohms. The current only is dependent variable with the value of the current, and it can be calculated. Alright, it shows I in amperes steps of 1 through on the y-axis, and then your ohms, your resistance, in steps of 2. And then you have your amperes at 12 over the amperes equals 12 over the resistance or ohms, and your E your voltage is 12 volts constant. Shows a grid line relationship curve. Given that the 12 volts and the resistance 2 ohms to 12 ohms, solutions is the amperes is equal to volts over the ohms. So amp is equal to 12 volts over 12 ohms, 1 ampere. 1 amp to 12 volts over 10 ohms is 1.2 amperes, and also 12 volts over 8 ohms is 1.5 amperes, and 12 volts over 6 ohms is 2 amperes. The process can be continue with the value of the resistance. You can see that the resistance is halved and current is doubled. With the resistance doubled, the current is halved. Illustrates another important character of the Ohm laws. Current varies inversely with the resistance. The applied voltage is held constant. Using the graphic shown in Figure 3.7 with the approximate value of the current is voltage at 12.5 volts, and you the graph with the Figure 3.8 with the approximate value of the current is resistance 3 ohms. Alright, your power, where electrical and mechanical pertain with the rate with which for the work is to be done. Work is to be done whenever the force can cause motion. Mechanical force is used to lift and move the weight. The work is done, however, the force is exerted with the cause of motion. Source of the force is compressed spring and acting between two fixed objects does not constitute work. Previously, it is shown that the voltage, electrical force, current flows into the closed circuit. However, the voltage, if the current does not flow because the circuit is open. Now the work is done. The similar spring with under the tension produced in this motion, the voltage coupled with the electrons to move. The work is done instantaneously. The rate at which the work is done is called the electrical power. The work is measured in watts. Total amount of work may be done at a different length of time. For example, given the number of the electrons moved at one point with another 1 second or in 1 hour. Depending on the rate at which they are moved, they're both the total work will be done in the same. However, the work is done in a short time of the watts instantaneously. Power rate with greater than the same amount of the work is done over a long period of time. As stated, basic unit of the power is watt. The power is watt is equal to the voltage across the circuit and multiplied with the current through the circuit. Also that the represents the rate at any given instant which work is done to be done. The P indicates the indication electrical power. Thus, the basic formula of the power is equal to volts times the amps, where E the voltage and I is this current through the circuit. The amount of the power chain, but either voltage or current over the both current. They also or both voltage and current are caused by the change. In practice, only factor that can be changed with the voltage and resistance because the plane the difference from the formula may take the current. Some more times presented with the quantity with which changed. Remember, if the current is changed because either the voltage or resistance has been changed, Figure 3.9 show the basic circuit using a source of power that varied between 0 and 8 volts, as the graph indicates with the relationship between the voltage power. The resistance circuit of the 2 ohms, the value does not change. The voltage E is increased by the increase of the voltage source that's up 1 volt from 0 to 8 volts by applying Ohm's law. The current ampere is determined at each step of the voltage. For instance, the voltage of 1 volt is the current over the amperes is equal to voltage over the resistance, or equal to amps is equal to 1 over 2 ohms, or half an ampere. You have your variable, E would be your voltage, and a resistor with a 2 ohms. The power supply would be is 8 volts, so you have about the graphing the power watts would be in powers of 5 increments of the P. Voltage in steps of 1, you have a fifth, a 2, a 4/5, and steps of is doubled, or divided by the power in power is equal to the volts squared over the resistance. So you have and also power in watts is equal to the voltage in the amperes. Sorry about that, I got off track. Power in watts determined applied by the basic formula. Power is equal to volts times the amperes, or equal to 0.5 amp watts. When volts is increased to 2 volts, the amp of the volts over the resistance of the 2 over the amps, 1 ampere. The power is equal to the volts times the amperes are equal to the power of voltage times the amperes 2 watts. This increases to 3 volts. The I and the ampere times the volts times over the ohms is equal to 3 volts over the ohms, 1.5 amperes. And also the power over the volts is equal to amperes over the 3 volts times the 1 amperes is equal to 4.5 watts. You should know that the voltage increased in 2 volts, with the power is increased by half the watt of the 2 watts and 4 watts at the time. The voltage increased to 3 volts, the power is increased to 4.5 watts, or 9 times. To show that the resistance of the circuit held constant and the power varied directly with the square over the voltage. Another way of proving the power varied with the square voltage is the resistance held with a constant. Since the amperes over the voltage ohms substitute for the power equal to volts times the ampere, you get the power is equal to volts times the volts over R, or the volts times the volts times R. Resistance equals power is equal to volts times volts, or A squared, volts squared over the ohms. Therefore, the power is equal to the volts squared over the ohms. Another important relationships may be studied with the figure 310 with the far beyond. The far power has been calculated. Voltage current of the power is equal to volts over the ohms and the voltage resistance. So the power is equal to voltage squared over the ohms. Before 310, note that the power that varies with the squared current with just as the voltage. Another value of the power and the current resistance of the factor is equal to power is equal to amperes squared over the ohms. This is called since the amperes the volts is equal to amps times the times the resistance. The substitution of power is equal to volts times the amps. You get the power is equal to volts times the amps times the amps. Power is equal to amps times the ohms times the amps, or power is equal to amps times amps times amps, or therefore power is equal to amps squared over the ohms. Alright, this shows you the voltage and a breaking point, the 0 to 8 point volts in the chart. Remember that R is fixed at 2 ohms, so you have voltage over the ohms, which would give you half an amp. You would have you have 2, 8, 18, and 32. Power watts is equal to amps over ohms, and your watts are on the side here. These are the 4 most important electrical quantities that have been discovered. They are voltage, current, resistance, and power. You must understand the relationship among the quantities we cover throughout with the study of electricity and proceed with the crafts. The power exceeds the express term and alternate power. The other 3 basic quantities over the volt and amp and ohms. In the practice, you should be able to express one with the quantities in the terms of the 2 others. Figure 311 is a summary of the 12 basic formulas. You should know the 4 quantities of the volts, amps, and the ohms, and the power. A summary of the figure of the adjacent with the each for the quantity with the three segments, and the note with each for the segment of the basic quantity expressed in terms of two other basic quantities. No two segments are alike. Or figure 311 shows your summary of the basic power and basic formulas. If you want the power, you got volts times or amps times the volts, amps squared over the ohms, and also you have the volt squared over the ohms, and if you want the amps, you have the volts over the ohms, and the power over the watts over volts, or the square root of the watts over the ohms, and also the resistance or the ohms is equal to the volts over amps, volts squared over the watts over the amps squared. And if you want the volts, you have the square root of the watts times the ohms, and also the power equal the watts over the amps, and amps times the ohms. For example, the formula wheel shown in figure 311 can be used to find the formula to solve the following problem. Circuit of voltage if it delivers 6 volt with a circuit even the 3 watts power with what if the resistance of the load sent to the ohms or the quantity they have been asked to find. Look for the section of the wheel with the ohms in the center of the segment. This equals voltage squared over the watts containing the quantity they have given. The formula would be that the ohms is equal to volts squared over the watts. The power can be used to solve that 6 volts is E over P watts is equal to 36 over 3 watts, which is 12 ohms. What is the term applied with the rate of the mechanical electrical force caused the motion? How much current will be changed in circuit? And how are the three formulas electrical power rating? Electric components are often given of the power rating. The power rating of the watts indicates the rate of which the device converts electrical energy into another form of the power, such as the heat of the motion, and the example of such rating noted within comparing the 150 watts with the 100 watt lamp. The higher the wattage rating, the 150 watt lamp would indicate the capable of converting more electrical energy into light. Energy of the lamp, lower rating. The other common example of the device of the power ratings are solid irons and soldering irons and small electrical motors. In some electric device wattage rating, they indicate the maximum power of the device designed to rather than normal operating of the power of the 150 watt lamp. For example, the 150 watts when operated with a specified voltage printed in the bulb of the contracted device with the resistor not normally given the voltage current rating. Resistor is given with a power rating with a watt that can be operated with any of the combination of voltage of the current as long as the power rating does not exceed within most circuits. Actually, power with a resistor considerably less power rating than the resistor of 50% safety with a factor U. For the example, the resistor normally 2 watts power. Resistor power rating with the 3 watts will be U. For the resistor, the same resistor value with available the different wattage value for the carbon resistor. Example, the commonly made watting ratings at 1/8, 1/4, 1/2, 1 and 2 watts. Larger physical size of the carbon resistor, the higher the wattage rating they true because the larger surface of the area material radiates a greater amount of the heat more easily. When the resistors such as the watt rating is greater than 5 watts are needed, the wire wound resistors are used, but the wire wound resistors may have the value of the 5 to 200 watts. 5 and 200 watts. Special type of the wire wound resistor used the power except for the 200 watts. But then other electrical quantities prefixes may be attached to the word when expressing the very large, very small amount. For some of the most common there are kilowatts, 1,000 watts, and a megawatt is 1 million watts, and a milliwatt is 1,000th of a watt. The current in the circuit of the 5 ohms, the resistance of the 180 watts over the power referred to figure 312. The type of the power should be with the current circuit described in the section 12. What power of the circuit is 10 amperage for the current over the 10 ohm resistor. Figure 312 shows the circuit with the competing electrical quantities. You have E, your voltage in the battery, your amps in the line, or A in the ammeter. Your power is 180 watts, and you also have a resistance of 5 ohms. So, I'm believing that it would be I squared over R. So you have Power conversion efficiency of the term of the consumption of the electric common electrical field applied with the use of the power, same sense for the gasoline consumption applied with the use of the fuel of the automobile. Another common term of the power conversion, power is used with electrical device and convert with one form of the energy to another. Electrical motor converts the electrical energy, mechanical energy, electrical light bulb converts the electrical energy to light energy, electrical range converts the electrical energy and the heat energy. Power used with electrical device measured in energy with the power of a human electrical device energy is equal to 1 watt of power used with the continuous for 1 hour. 3 kilowatt hour is more extensively on a daily basis that is equal to 1,000 watts an hour. It's 1,000 watt hours. The efficiency of electrical device for the ratio power converted to the use of the end of the divide by the power consumed with the device for the number that's always less than 1 because of the loss of the electrical device. The device has any efficiency rating with a 0.95 of the effectively transform 95 watts into useful energy every 100 watts of the input power. The other 5 watts are lost to heat, other losses which cannot be used. Calculating the power converted with electric device, simple matter. You need to know the length of the time the device operated with input power with a horsepower rating. A horsepower unit work with is often found with the rating of electrical motors. 1 horsepower is equal to 746 watts. Example of 3 quarters of the horsepower operates an 8-hour day with the motor for the power converted with a month motor per month. However, the kilowatts per hour does this represents. The time is 8 hours and 30 days, so you have that would be your time. So you'd have 240. It is your time. Your power would be 3.3 quarters of the horsepower. Convert the horsepower to watts. You have the horsepower in the 746 volts, or 764 watts for 1 horsepower. 3 quarters of the 746 watts, and then you have the power is 559 watts. To convert the watts to hours, you have the 559 watts times 8 times 30. It's a 134,000 watts per hour. No, the figure is rounded to the nearest 1,000, so to convert the kilowatt an hour, the power is equal to power in watts hours over 1,000. So you'd have 134 kilowatt an hour. The motor actually with 137 kilowatt per month with efficiency of the motor, given the power converted with 134 kilowatts per hour. Power used 137 kilowatts per hour. The monthly the solution is the efficiency if it is equal to the power converted 134 kilowatts per month over the power used 37 kilowatts per hour with its rounds to the 0.978 round with the 3 figures. How much power is converted in 1 horsepower motors in 12 hours? So you'd have 12 hours one day, 746. I believe it's 746 watts, and 12 hours. So 1 horsepower would be 746 over 174.46 times the 12, which would give you the times the power of the time of 12 hours. It will the efficiency of the motor equal to 9.5 kilowatts or 9,500 kilowatts an hour in 12 hours. Series of DC circuits. 2 unequal charge of the connected by a conductor complete pathway of the current exists and electric current. Electric circuit is believed with the conducting the pathway consists not only with the conductor but also includes the path of the voltage source inside of the voltage source of the current flow of the positive terminal through the source are merging together at the negative terminal. Series circuit with a characteristic series circuit is defined in the circuit contained with one path of the current flow that complete basic figure that has discussed and become more complex with the circuit with the figure 313 show the 2 circuit the basic circuits have only 1 lamp in the series circuit with 3 lamps connected in the series. Show the basic circuit would be positive and negative, completing the DC circuit from the battery to the first lamp, and then your series circuit would be all the line. Your battery supplying all on the same circuit would be a series circuit with a continuous 3 lamps. Resist all 3 connected all to the lamps. Refer to figure 313 with the current series with the must flow with each of the lamp to complete with electrical path with each of the additional lamp off with the added resistance. In series circuit with the total circuit the resistance is R to the T or is equal to some of the individual resistances. You'd have resistor 1, resistor 2, the resistor total is equal to the resistor 1 plus resistor 2 plus the resistor 3, or the number in the series, the number of the resistors in the series. Note the subscript that denotes the name of the number of additional resistors that may be made in this equation. Example of figure 314 series with a circuit consisting of 3 resistors, 1 ohm of 10 ohms. one of 10 ohms, one of 15 ohms, one of 30 ohms, is shown the voltage provides the source of the 150 volts. The total resistance would be 140 volts over the 10 ohms, 15, and 30. Show that if given them with a resistor 1, you'd have to add all these, which would be basically 55 resistance over resistance 55 ohms, and you'd have a 110 volts. So you'd put the E equals I over R. So 110 volts divided by 55 is 2.2 amperes. Some circuit application for the total resistance done with the value of the one circuit resistor to determine the equal of the resistance total. Resistors totaled by the resistance 1 by resistor 2 by resistor 3, the transform sum of the value unknown resistance. Example, figure 315 with the total resistance circuit contained with the 3 resistor 440 ohms and 2 with the circuit with the 10 ohm each, with the calculate the value of the with the third resistor. So you'd have 10, 20, and 10, 10, and also I'm guessing you could do 20. So resistor 3 was 20. Current circuit in the series circuit. So there's only one path of the current series circuit, with the same current must also flow with each of the components circuit to determine the current of the series circuit, that only through the current through one of the components needed to be known. The fact that the same current flow with each of the component with the series circuit they may be verified with the inserting the meter for the circuit with the various points that is shown in the figure 316. If the were done, each of the meter have been found to indicate such value of the current. Alright, this is the current in series circuit. Show the your resistors also 2 amps amp. I guess that's, I'm pretty sure that was these are voltage in series. The resistors are given the value of 10, 20, 40, and 30, and 10, 20, 30, 40. You have 2 amperes, or 2 amperes, 3 amperes, 4 amperes, and a resistor of 30. So you got 10, 30, 20, 10, 20, 30, 40, and amperes at 200 volts. Voltage drop the graph of the resistor consisting of a single resistor voltage of the total voltage circuit is equal to the amplified voltage of the total voltage series of the consists of the more one resistor equal to the voltage that consists of the sum of the individual resistor voltage drops. Series circuit circuit, if the sum of the resistor voltage drop of the unequal source such of the voltage statement the proof in the examination circuit shown figure 317. The circuit shown is the voltage total equal of the 20 volts to drop the curve of the series circuit with a consisting of 2 ohm resistors. Total resistance of the resistors total is equal to the sum of the 2 individual resistance of 10 ohms. Using the ohm laws of the circuit, the current will be calculated as the voltage totals at 20, resistor totals at 10 ohms, which equals amperes total is equal to voltage total over the ohms total, which equals to the 20 volts over the total with over the ohms total is equal to 20 over 20 volts over 10 ohms, which is equal to the amperes of 2 amperes. Figure 317 calculated individual voltage drops in the series circuit show that the 20 volts to resistor 1 and 2 that you have the voltage total of the 20 volts over ohms, which give you 10 amps. So then, so the value of the 10 volts, resistor. The value of the resistor known as the 5 ohms over the current of the resistor, for the known to the 2 amps voltage drop of the resistor, calculated the voltage E across the resistor 1. Given the amps are 2 amp, the resistor is 5 ohm, the voltage total is equal to the 2 amps over the 5 ohms, which equal the voltage is the subscript 1. 10 volts by expecting the circuit each of the resistor 2 the same magnetic value of the resistor 1 carry the same with the current, but the voltage drops across the resistor 2. Therefore, the equal in 10 volt with additional 2 volts drop together the total drop of the 20 volts exactly equal to the voltage. Therefore, the series is equal to voltage is equal to E1 equals E2 or E3 plus E4 equals to E to the number to the certain number subscript. Example, series circuit with a 3 resistor having value with 20 ohms, 30 ohms, 50 ohms, respectively, finding the applied voltage current with a 30 ohm resistor with a 2 amps, and also the abbreviation amps commonly used with the amp to solve the problem. The circuit diagram is first drawn and labeled figure 318. Or we're trying to find the volts from the battery. There's 2 amps going from resistor 1 is 20 to 30, which gives you a 10 volt or 2.3, which equals 50 volts. So you got 50 volts for the first side, which would be 4 amps, and also, but it's going this way, and then the reverse, the resistor would be 1030. Let's do this right. The 50 over 50 with 100 volts resistor. So resistor 1 is resistor 2 is equal to 30 or 50 amps with equal to 2 amps, like I said, and then you'd have the your voltage is equal to E1 to E1 to E2 would be 20 ohms. 20 ohms voltage, or 2 amps, and then half an amp, and then, alright. We'll just go through the solution. Resistor 1 is 20. Resistor 1 would be 20 amps, resistor 2 is 30 amps, resistor 3 is 50 amps, equals, with an amperes of 2 amps, I guess that's, and solution would be the, I didn't know if that was all amperes of the 2 amps on the side. The voltage equal to, is minus E1 plus E2 plus E3, E1 plus resistor 1 plus amps terminal, the current through the resistor 1. E2 is equal to the resistor 2 plus amperes 2. Amperes 2, E3, voltage is equal to the resistor times the amperes 3. So E2, the first one would be the resistor, the first resistor from with amperes would be 2 amps, or 20 amps divided times 2, and then your resistor 2 times the amps would be 30 amps times 2, and then your resistor 3 would be the amps times 50 amps times 2, which equals 40, 60, 100, 200 volts. Would be the battery. Testing. Alright, note when the ohms level, the quantity of the equation must be taken with the same authority but the circuit above the example. The voltage current with the resistor 2 we can be using the current with the resistor 2 with the resistor 2. The value of the voltage drop of the resistor to determine the applied voltage in the proportion circuit of resistance. The voltage drop of the curve of the series circuit with the direction and proportion resistance. This is the result of having same current flow with each of the resistor, with the large with the ohmic value with the resistor, large with the voltage drop across it. Circuit consists of 3 resistor with the 3 amps, with the resistor 1 20 amps, the resistor 2 60 amps, and the resistor 3 of 80 amps. What is the total amount of resistance such for the voltage of the circuit? Where the voltage drop of each of the resistor of the circuit is described in this question 17. With the current with the increase of 4 amps, what would be the voltage drop across each resistor of the circuit drawn described in 17? What would you have done with the circuit described in question 17? The increase of the current with the 4 amps. The power is in the series. Power is in a series circuit. Each of the resistor of the series circuit can consume the power which is dissipated from the form of heat, but the power that comes from the source of the total power of the equal of the power consumed by the circuit resistance in series with the whole power of the equal to the sum of the power dissipated with the individual resistors. Whole power total is equal to the power times power 1, power 2, power 3, and power to whatever power. The example of the series of the constitutive V3 resistor with power to the log value. Log having the value of the 5 ohms, 15 ohms to find the total volts of 12 volts, 15, 12 volts, 120 volts applied with the circuit. 120 volts at so you'd have your resistor power is equal to resistor 1 would be 5 ohms, resistor 2 10 ohms, resistor 3 15 ohms, so you have and 120 volts for E. The resistors total would equal 30 ohms, and the total resistance applied with equal to the voltage equals the voltage total would be 120 volts over the 120 ohms. Would be 120 volts over 30 ohms. Equals 4 amperes. The mean of the power formula with the calculated with equal to the resistor 1 of the power of 1 of the amperes 4 amps times resistor 1 or 5 ohms 80 watts. The power 2 would be 4 amps times 10 ohms. It's 160 watts. Power 3 would be 4 amps at 15 ohms. 200 watts. Total power would equal 80 watts, 160 watts, 240 watts. Total power 480 watts. Check the answer. Total power with delivered to the source to be calculated. Power source is equal to I source amp source over the volt source. The power source is equal to 4 amps times 120 watts equal to 480 watts. The total power is equal to the sum of the power of the individual resistors. Summary of characteristics. Important facts of the governing of the operation theory for the circuit listed below. The factors will be set with a group of the rules, so that they will be easily started. The rules are complete when they understand before the start of the more advanced circuit is undertaken. Rules of the series DC circuit. The same as the current flow of each large series circuit with the total resistance. Series circuit equal to the individual resistance. Total voltage across the circuit. Series circuit is equal to the sum of the individual voltage. Drop the voltage, drop the graph of the resistor. Series circuit with the proportional automatic value with the resistor. The total power of the series circuit is equal to the sum of the individual powers of each of the circuit component. Series circuit analysis. To show the procedure following the series circuit with the following sample of the problems will be solved. With example, the resistor 5 ohms with the 10 ohms, 15 ohms are connected with the series of the power with the source of the 90 volts shown in figure 320 with the total resistance current at the voltage drop of a resistor over the power each of the resistor total power circuit. The voltage is 90 so you have a resistor 1 plus resistor 2 plus the resistor 3 would be 25 ohms and solve the circuit of the resistance. The five must be found with the circuit over the can be current known with the voltage drop. Also the resistor 1 over the so you have 90 volts, and also the resistor would be 5 ohms, would be 30 ohms. So we'd have to take the volts over the volts over the ohms, which gives you 3. So you have amps, and then you figure for each amperes, each resistor, and then you figure out the power of the amps or the power of the watts in total. For example, the resistor the 10 ohms, resistor 2 ohms, resistor 3 ohms, 50 ohms, resistor 4 ohms are connected in series with the power circuit. Here, the 321, but the current in the circuit is 120, 1/2 amps. What if the battery voltage? What if the voltage got the resistor? What if the power expand with the resistor? What if the total power? You have the voltage. Also, the amps are running on 0.5 amps. So your first volt would be so we have E equals amps over ohms, which would be 5 volts for the resistor 1, and then another, I'm not sure. Alright, resistor 1, resistor 2, 5 amps. Sorry, I'm trying to do them individually. Resistor 1, 10, 20, 20, 30, 50, 100 volts, 5 amps. Your amperes would be, you have 110 ohms or resistance, 110 100 over 5. All right, let's just continue. It's important fact that the key to the level of the oscillator series consider whether the value of the component value of the total value information enables you to use over the ohms level of total resistance, find the voltage, total current, total value to be inserted by the formula to total resistance. To find the voltage, you have the ohms total over the voltage total over the amps total, which equals the amps. The volts total equals the amps total equals the ohms total. The current total is equal to the amps is equal to the volts over the ohms, and also the note is equal to the series circuit. However, the distinct between the amps and the formula should be known with the reason for future circuit that may have series Several currents will be necessary to differentiate the voltage over the other currents. Compute with the voltage and amps and ohms and power associated with a single given resistor. Value with the formula obtained with a particular resistor. For example, to find the value of the unknown resistor voltage across the current through the particular resistor must be used to find the ohms equal to volts or resistor. Volt ohms times amp ohms. The voltage cross is the volt ohms times the amp ohms to the ohm. To find this, you have the amp ohms over the volt amps over the ohms. So if the two resistor, the resistor 1 is 25 ohms, the resistor 30 is 30 ohms. The circuit is 6 amps. What is the source of voltage for the drop of each for the resistor, total power, and D power each for the each resistor. All right, and we're going to cut the tape there.